All right. Hi, everybody, and welcome back to our weekly stream. My name is Johannes and I'm a instructor for deepdives-eu. Background is in development, data analytics, machine learning. And with me, I've got, as always, my friend Mikko with a similar background.
Hi there.
Welcome.
Thank you.
So our topic for today that I picked, my turn this time, is MLOps. And the idea here was that we had a talk on DevOps not too long ago, where we talked about what that actually means, what the generic parts of that are. And then I thought that the time might be ripe to try to extend that into MLOps. This might also sometimes be called data ops or AI ops, but the idea is roughly to take the same kind of operations procedures and best practices into the machine learning world. And Mikko, if I can ask you, what is your kind of view on MLOps? What is it in your opinion? Then we can start from there.
That's a good question for a person who doesn't know about that too much, and I hope you will clarify this whole thing today. I'm here to ask stupid questions, beginner questions from you, but my understanding is that MLOps is something similar to DevOps. It solves a problem of having many different complicated things that need to be stitched together to have some sort of a process which is manageable.
Exactly.
Something like that.
Yeah. So
was it even close?
Yeah. So the reasoning why do we need MLOps is similar to why do we need DevOps. Like when we talked about DevOps, we talked about the kind of old way of doing software, which had problems in it. And then DevOps kind of tries to solve those problems by introducing methodologies and ideas into the process. And MLOps is roughly the same thing. It's just much younger, right? So it's not too long ago when kind of machine learning projects were kind of literally moved from a data scientist's laptop into a production environment, without any proper software development methodology.
Sounds like the way we did software back in the 90s.
Exactly. And it's exactly the same thing, but just kind of more recent. And the reason for
Except
that
we
is...
didn't have laptop back then.
No, there was workstations. You're right. But yeah, so the reason is kind of similar, that the data scientists, I'm using the term kind of loosely here, but the people who were working with machine learning very often had no prior professional background. So they would have been working with machine learning at universities, working on research projects, and so on. And then they would kind of lack the kind of process that we are used to when doing software development. So of course, we all know that what that results in, it's going to be huge problems. And this is not to take anything away from the data scientists. They are wonderful people, and I might include myself as one of them. But the idea was that the methodologies that people used, like working with a data set on your laptop in MATLAB or R, don't really translate into creating a production-ready machine learning, service or anything like that. So that was kind of one of the big problems. And of course, everybody or very often these projects would succeed still, right? So people would be able to create a production version. I know how to run MATLAB as a server. I know how to run R as a server as well. But we're kind of missing a lot of the things that we're used to from the software development world. this kind of idea of the server being always on, right? So if in case it crashes, it would just restart. Well, that doesn't happen automatically in that environment. And then these deployments would also be kind of one-time deployments. There would be no kind of iterations with that. All of the iterative stuff would be happening on the laptop. And then kind of once we're happy with the machine learning model, I guess, or how it's working with some test data, then we kind of freeze everything and deploy that into the production environment. And then we never update it again. And as we know, projects don't work like that, right? So in machine learning, the world changes, models need to be updated, and so.
I have one point there that when back or probably still, well, not anymore, but when you had your in the 90s or before that, you have had electronics, those like computers or radios or whatever, those were built just like that.
Yeah.
They were built once and then they went into production, something was produced and delivered, and you weren't able to update them at all afterwards.
Exactly.
So we have had processes that actually work like that, and pretty well, I guess. But then came software, and you were able to just deliver whatever into production because you basically knew that you can update it later on, right?
Yeah. So with machine learning, however, there is one very important thing that happens, which doesn't happen with software. That's concept drift. Concept drift. So the idea is that you have trained your model at time t with the data then. However, at time t plus something, the world is different. So the sample data that you used for training your model might not be a good sample of the modern world anymore. Think about stuff like best next sales offers with let's say that you're in
what kind of time frame you're talking about here, like a week, a month?
Could be anything.
Yeah,
depends on
basically
the
software
context.
with software the world does change as well, laws changes, and so basically that kind of happens with software as well, but probably it's much it happens much more fast with machine learning.
The kind of problem with machine learning bias drift or concept drift is that it's difficult for us humans to see, right? So in the software world, we kind of know about that.
Yeah. The specification changes, or yeah.
But I have an example here. So let's say that you're an e-commerce store and you sell iPhones, right? So previously, iPhones came with a charger, both the cable and the physical charger. But then at some point, Apple actually stopped adding that charger to the iPhone package. So if you're an e-commerce store and you have a machine learning model where you want to, give people a good deal on some add-ons once they have bought their iPhone, the old model would be, I don't know, suggesting some wireless headphones or something like that. Whereas the new model should clearly suggest a charger, right? Because that's going to be the most used additional utility for an iPhone. And this is just due to the world changing. So if you've trained your model based on old data, you would see that nobody buys a charger with an iPhone. People only buy it afterwards once the one they have is broken or something like that. Whereas nowadays, quite a lot of people need to buy a charger with their iPhone. So the world has changed. So you need to retrain your machine learning model. And these changes are quite subtle. So it's kind of...
It changes a little day by day. More and more people want to have a charger with their phone as well.
Yeah, and it's really difficult for us to figure that out, what the change has been or whether there has been a change. So this again goes back to observability. But that's kind of the motivation why in machine learning we really need to have in place a mechanism to be able to update the model. And now, if that original model was trained on some data scientist's laptop. Do we have all
Who's
of
no
that
longer
training?
working in the company anymore.
Yeah, right. And that's why we need MLOps to kind of define these.
So here's a stupid question. Why don't you just update the model all the time?
Because it costs you.
Okay.
Like, why fix it if it ain't broken?
Yes, but
That's
since
your
it's
favorite.
changing all the time, how do you determine at what point you want to update your model?
Yeah, that's a good question. So this goes to kind of observability of machine learning. Let's see if I have.
And tell me when my
something-
questions are off topic from the MLOps point of view.
No, they're not. They're not at all. So I think this is the life cycle end to end. So you're talking about monitoring and logging here.
Mhm.
The top right, let me try to zoom this a bit. This is a nice website, ml-ops.org. So the top right-hand side over here, monitoring and logging. And you can see that there's something here called a model decay trigger. So what we can do very often is we can try to figure out how well our machine learning model is doing. And now the problem here is that we often don't have a feedback channel. Think about something like credit card fraud, right? You're trying to, from all credit card transactions, flag the ones that are likely fraud. The problem with your prediction is that you don't know whether it was true or not. Because if some fraudulent transaction comes in, it takes quite a while for the customer to complain. You know, it could be like a month before they get the bill, and then they figure it out, and then they complain. So the feedback cycle is very, 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 very long. So we can't use that as our metric on how well our model is doing. But what we can use is a couple of other things. So first of all, we can use the distribution of our predictions. That should be static. If our distribution of predictions changes, then something has changed in the world, right? And of course, here we need to take noise into account. So if it has changed dramatically. And sometimes that's not even good enough. Sometimes we actually take a look at the incoming requests. So how do the distributions of the incoming requests change over time? And then that could give us the trigger. Okay, something has now changed because now we get a very different distribution of requests than when we were training the model itself. So that's what is kind of triggering this workflow or pipeline. And that gives me the possibility to start to go through the pipeline, if you're okay with that.
Mm-hmm.
So in a machine learning pipeline, we're very often detaching the data pipeline from that. So that's here in yellow, right? The data pipeline is kind of its own beast. It has problems like how can we access the data that we need for training? What kind of transformations we need to do to that data to clean the data? It might be dirty to start off with. So that's kind of its own process over here. And in theory, we can say that we're getting more data as the world goes on, and the data pipeline works by updating the data into our data repository, but we don't necessarily always use that new data for training, right? If our machine learning model is already working correctly, then we're just in the data world over there. And then basically, when we get this trigger that we want to retrain our model, then we go through the training pipeline. So this is roughly in, what is this, orange or red over here, where we train the model using maybe previously known parameterization. And then we test the model. And then during that testing, we make sure that it works better than the currently working version. Right? And this, of course, is always dependent on the test data that is being used. So we want to make sure that the test data is representative of the current world. The training data can be combined of both the past world and the current world, but the testing data should always be with the current world. And then it might be that the world has changed so much that just adding more data, doesn't fix the problem that has come up. So in that case, we then might need to do some model engineering as well. So maybe change the algorithm, maybe change some hyperparameters in such a way that we get a reasonable model out of that again, a model that works better than the current version. And now, previously, this would have been done manually, right? So like a data engineer would have been called, and they pull up their laptop, and then they type a lot, and then something comes out.
Mistakes.
Yes.
Use incorrect parameters, and yeah.
Exactly. But now with MLOps, the idea is that all of this happens automatically. So the data itself can be in a system called a feature store. So any new data that comes in through the data pipeline automatically gets added to this feature store, which is kind of a versioned repository of the training data that you're going to be using. And that then allows you to also do comparisons, right? So you can always redo the training on the exact same data set that you did previously. So you can see how some model engineering has actually affected your model independent of the data changes. So that's important. And then the other thing that is very important is that the model that we're creating when we're doing the machine learning also goes into an artifact repository.
A question: would the data go to the feature store at the point of time when you realize that things have changed, or would it go there all the time? How does it get to the feature store?
It depends on how you want to do it. So generally speaking, having data in a feature store might be more expensive than having it in the data. So you could have your data pipeline just dump the data into a data lake and then pull it into the feature store whenever you're doing the update. Or you could have the data pipeline go all the way to the feature store as well. It kind of depends on
independent of what is happening in the other parts of
Yeah. So
I
the
was
data
just
pipeline is kind of independent from the machine learning pipeline, but they have this integration point, which is either a data
I was just
lake.
wondering about since storing data costs you.
Exactly.
And if you choose the correct way to store the data, it's less expensive. But if it's something that needs to be active, then it costs a little bit more. And if you're versioning ridiculous amounts of data, then that will actually cost you something.
Yeah, but versioning of data in a feature store is basically additive.
Okay.
So
it's not like
the versioning is kind of selecting which parcels of data you're using for a training job.
That's good.
Yeah. So then we have still left this blue part. So that's kind of the traditional DevOps part. So there we have some code that is then going to be part of the deployment. This depends on how managed your environment is. Like all of the cloud providers have managed environments where you actually don't need that blue part at all. Basically just take the model and then give it to the cloud provider service, and then it will make it available for you. But in case you're integrating this maybe into a mobile device or something like that, then of course you would have code as well. And we have this kind of integration point where when either the code or the model changes, we then need to redeploy that bundle onto our endpoints, basically.
Like edge devices even, or?
Could be edge devices as well, yeah. So quite a lot of this is happening now, especially with Gen AI, a lot of the providers have come up with these smaller large language models. So I don't know.
Large language model.
Yeah, it's like a medium language model then.
Yeah.
Right. So to fit them onto phones and mobile devices and do local inference.
Yeah, much better usability then. Or I don't know, much better, but better usability if it's basically instant compared to. Yeah.
So there are a couple of points here that we can use to trigger the retraining of a model. So like I said, we can use the data that we get from the production environment. So there we need to have something in place that is constantly looking at the distribution of the incoming requests and the distribution of the outgoing predictions. And in addition to that,
when you say distribution of the incoming requests, do you mean that like the content of the requests, or the frequency of when they come in, or content?
Okay. The content. Now we lost Mikko, apparently. I guess it's okay for us to learn about how this actually works and what kind of problems we can get into with this. But yeah. So where was I? I was in us explaining how we know that our model is no longer current. And one of the options, like I said, is just basically to log all of the incoming requests for predictions, and then also to log all of the predictions, and then to see how that distribution changes over time. When there is a large change, then that would, of course, mean that we would be interested in maybe updating our model. Another place where we can take a look at this is actually in the data pipeline. So similarly, that we can take a look at how the incoming requests change. We can also try to take a look at how the training data changes. So if there's a big change here in the data pipeline, then that might give us an idea of the world having changed and us needing to do some kind of retraining. Yeah. So MLOps is a kind of a way for us to move away from the idea of just doing machine learning as a project on single users, laptop and stuff, and moving towards a more structured methodology, similarly to what DevOps is using. And we can actually see some commonalities here. So we have this pipeline, which is where we have multiple pipelines, right? So we have, there we go.
Let's see if my microphone is working.
Yeah, seems to be working. So we have pipelines. So similarly to a CI/CD pipeline in DevOps, we have a separate data pipeline where we're ingesting data, transforming it, making it ready for machine learning. We have a separate machine learning pipeline where we're training a model from a specific set of data. And then we have separately a deployment pipeline that then deploys that model together with any kind of code into the production environment. So similar things. There are other things in DevOps that don't really make much sense here. Things like microservices don't really work. However, other things like infrastructure as code is very important here as well. We're trying to make sure that the machine learning project itself is not really dependent on a single user or the knowledge of just one person.
Or manual operations of single users.
Yeah, so using kind of standard. Yeah, so the cloud providers are good in in that they basically require you to standardize how to deploy your machine learning.
Yep.
So that gives us this kind of security with regards to production deployments.
So this really sounds like DevOps.
Kind of, yeah, right?
It's like the concept of and the reasoning why you have this, or parts of the reasonings are like, well,
yeah,
you don't want individual people doing random things, maybe correctly, repeatedly, week after week, or especially if that something happens 1 month later or half a year later, you don't realize all the individual steps that you actually did last time. You don't remember them, and you make mistakes, and that's at least that problem probably gets solved with
and that kind of part of making machine learning an enterprise ready technology. Because previously, even if the software stack would have been properly handled, these machine learning projects would be kind of swimming against the current. It would be like crazy people with long beards installing weird packages onto servers. That would be it.
How about then the high availability? If you're a single person individually deploying something into a production, it sounds like that you're deploying a server or something into a server, but you want to have, if it's a production ready system, then you probably have to have high availability, and that makes immediately things quite complicated from the manual labor point of view.
Yeah,
if you do things manually.
Yeah, that's kind of why I'm saying that the cloud providers have made this better, because they define different kinds of product that then do the machine learning model hosting, and they then have high availability built in. So it goes away from the domain of the actual data scientist. It's just part of the platform nowadays. Similarly, then durability for the data and all of this stuff. And a lot of things, like when we're deploying, is done in using technologies that are well known from DevOps. So we do things like blue-green deployments. However, in machine learning, because of the slowness of the feedback, it might actually be that we're doing something called shadow testing. If you've ever heard of that.
That's a new term for me.
So shadow testing means that we're running two versions of the model simultaneously, a little bit like blue-green deployments. However, we're only replaying the requests that come to the production model to the new model. Mm-hmm. And then instead of giving back the predictions to the user, we use statistical analysis to see how they differ from the previous version of the model. And then we can try to think whether we want that difference or whether something has gone totally wrong. So that's kind of one of the differences you can see.
But that long feedback loop is a challenge in many things, I guess.
Yeah, but that's exactly why we use these shortcuts.
But maybe it's not with every project, right? Depending on what you are trying to predict with ML.
Yeah, exactly. So like if you do ad positioning, then you have a fast feedback loop. Mm-hmm. So the way ad positioning works is that an ad framework will predict which ad you would most likely click based on whatever they know about you, and then they display that ad. And then if you don't click on it, then they immediately have the negative feedback. So it's like 5 seconds, and that's it. So very different from like a credit card fraud thing. But we actually, this is one of my favorite topics in DevOps as well. The KPIs that we actually want to improve are not directly measurable. Like with an e-commerce site or maybe even a video site like Netflix, what we want to improve, like for an e-commerce, is the amount of turnover, so sales, but no returns, right? So we know the amount of sales fairly quickly as people go and click through, but then people could always cancel their orders or maybe return it. They didn't like it after all, so on. So those are kind of slower things. But we know that the sales itself gives you an idea, right? It gives you a pretty good approximation. And we actually have even better approximations, even faster approximations. In e-commerce, we have latency. So we know that the longer it takes to produce a page in an e-commerce site for the end user, the less likely they are to buy anything. So we can use these kind of shortcuts, these kind of technical metrics to try to predict, unintended, the actual metric. And there are these shortcuts available in different fields always. And then we maybe try to look at those. Of course, testing that hypothesis that it actually does have an effect on the actual metric that we want to do. The other thing that, while we're at the topic and we still have some time left, one of my favorite things, or two of my favorite things regarding machine learning projects. One, does it need machine learning? So this is no longer as important as before, but like 10 years ago, when machine learning was the new hype thing to do, you get people from the top of a company, like the managers, saying that, can we please add some machine learning to our product? And then you're like, it doesn't need any machine learning. But
yeah, this sounds familiar.
Yeah, so a lot of AI, remember, is not machine learning based. The majority of AI is search based. That's not machine learning. So just kind of think when a thing comes in, does it need machine learning, or can it just be solved using a simpler? And then the second thing is, when you're starting the project, make sure that you know your target. Like, let's say that we're doing fraud detection. Mikko,
do you mean by target? Do you mean like the metric that you're trying to improve, or
exactly? So,
okay.
Mikko, you are now the new manager of Mikko's bank's credit card department, and you are buying from me a fraud detection system. So, what is the metric that you want to optimize?
I'd like to have less fraud.
Perfect. I can give you a solution that will give you zero fraud.
And I know that you will just shut down the website that generates sales, and then there's no fraud.
No, I will actually make a machine learning model for you that will just always say for every single transaction that it is fraudulent. That way, you will get zero fraud because you block those.
So you need to know what is more important to, and this probably, and I know this depends on your field where you're operating in, but you want to minimize false. Well, it depends what you want to minimize.
Exactly.
Do you want to have more sales, or do you want to have less fraud, or you want to increase sales and have less fraud without then blocking those legitimate sales by falsely detecting them to being as fraud? So what would you say if I'm my company is selling cameras, like digital cameras? So what would be the correct? You will now have to educate me, since I'm a manager. I don't know anything, and then you say that, yeah, but you just have to give me a metric, and I don't know the metrics, so you have to very briefly explain to me so I can make an informed decision.
Yeah. So what you want to do is you want to minimize the truly fraudulent transactions while maximizing the non-fraudulent transactions. And now this is not a binary decision. So the model, in this case, most likely it's going to be a binary classification problem, and a lot of the problem solutions actually give you a propensity score or maybe a probability of how likely this is to be fraudulent, how sure this model is
Mm.
that this incoming transaction is fraudulent. And then you can experiment, like see how much risk are you ready to take for a fraudulent transaction to come through, while still leaving enough of those.
For example, I'm probably okay if my sales increases by tenfold and I get 2 extra frauds there, then maybe that's okay.
Exactly, and that's what needs to be done.
Okay, give me an example of a field where you want to just have absolutely no mistakes, and so that every fraud or whatever the thing is that you're trying to catch is caught. Give me an example.
Healthcare is an easy one here. So
Mhm.
if you have a system, like there are these image recognition systems that try to look at X-rays or MRIs to find tumors in them, and then figure out whether the tumor is malicious or benign. So there you want to err on the side of malicious, right? So all of the things that are clearly not a problem, the automated system will take care of. And then if there is even a little bit of a doubt of whether it could be a malicious tumor, then send it to a manual process to a radiologist.
And actually, if someone was like in the past, this was done manually, everything was done manually, then that was not that. I don't know what's I tried to not use the correct words here, but that was not that accurate, meaning that since you have a lot of X-rays or whatever images you have to go through, eventually you will make mistakes because you have to go through thousands of images. But nowadays, could it be that the machine learning algorithm is even better catching those problems than humans?
Yeah, so there are some use cases. I don't remember the exact details, where the machine learning algorithm has been better than the doctor in finding those problems. But this also has to do with psychological factors, like let's say that you're a doctor and you're like there's like 1% chance of something being there that shouldn't be there. So you only one of the 100 pictures that you look at will actually have that. So we as humans, we get tired with those kinds of situations because it's always going to be nothing to do. Just lose concentration. Now, if the machine learning algorithm can take even just half of those clear cases away from you, then you're already more alert because there's going to be more of those problems.
This makes so much sense. Just like the screening process at the airports.
Yeah.
They are not that often. Well, in Finland at least, there are not that many guns going through the X-ray or whatever the technology is nowadays that they're using. But so they actually insert images of weapons and things that you need to catch into the stream of images that the people have to watch at or look at.
To keep you alert.
Exactly.
Yeah, so that's kind of one way that kind of indirectly machine learning can also help. So it's not fair to compare what a doctor has been doing with like the whole set of data compared to what they're doing when they're being pre-sorted.
But if we go back to the MLOps here, you mentioned there that part of the process is maybe when you it's the now the model part, the biggest red text there. So you might have to change the model at some point.
Yeah.
And if I'm thinking this from like software developer point of view, if you have a large project and then you have to refactor something, that's usually a big task, and you are breaking a lot of things there while you're doing it, and you have to fix them as well. So it's usually not a trivial thing to refactor something, even no matter how careful you are, there are always going to be mistakes, and you have test cases and all that. So how would you now, if you need to change the model, let's say you are, let's go back to the fraud part. You have model X that is pretty good at detecting fraud, but then there comes a new model from somewhere, and it's much better at detecting just the kind of fraud that your business is, or my business. I'm the manager here, so
Yeah.
my business is there's a camera fraud detector which is very good at detecting the frauds in my field. So what would you then do? How does it work in an MLOps pipeline? What are the things that you would now have to do?
So literally, there would be no change.
Okay.
So the idea is that the pipeline is so generic that actually what we're doing here when we're doing training is we're usually running some kind of container using a standard input and output definition. So it doesn't matter what algorithm you're running inside there. And then similarly for the deployment, it's another container where we just put in the input and then we get out the output. What is interesting here is that there are also containers in front, like in a pipeline way, in front of and behind that training/inference container that can then do data regularization, right? So if your training data has been cleaned or transformed in some way, maybe we've done some normalization of a particular field, then of course when the request comes in, that data needs to have the same transformation done to it as well. So how do you do that? Well, it's just part of that container, right? So when you've done the data transformation, that same script written in pandas or something is going to run in front of every single incoming data request or prediction request. And then similarly at the end, like if you want to do some changes to what the model actually emits, then you can standardize it through to whatever you want to. This could be like
this is beautiful. And I can immediately think that, okay, the model that you are, the new model is maybe outputting something that needs to be scaled. Maybe it's a numerical value that needs to be scaled so that it's compatible with whatever happens after the predictions.
Yeah, so all of that should be.
This really makes sense.
Yeah, and then so that's kind of the idea. So the only thing that really changes, or that could change, is the environment, the infrastructure that you need for your model. So when do we change models or algorithms? Well, usually that happens when our original model was a simple model, and the world when the model was trained was simple. So it was complex enough to fit the data. We got good results out of it. Now, if the change in the world has not been such that the data has changed, but that the complexity of the problem has changed, then we might need to change the algorithm. Like we might need to go from linear regression to boosted trees or forests, or maybe all the way to a neural network. Right? So then the complexity of our model becomes bigger. That has nothing to do with the input and the output. Those are still going to be exactly the same. However, now it's going to take you longer to train that model. It's going to use more computation. Similarly, in the inference phase, it might use more computation to create the predictions. So there's this second level of technical metrics that we are viewing to make sure from an ops point of view that we get a good service for our end customers, so that we don't get too much latency, for example, when doing predictions, and so on. So that's kind of what we need to take a look at, specifically if you're making your model more complex than what it was before. But it's cool stuff, right? And
yeah, definitely. And the whole thing makes, as a software developer, when I look with a software developer eyes, when I'm looking at this really makes sense to have a standardized environment with clear, let's say, basically APIs that you're invoking, and then something happens after that. And yeah, this is very good. This is very good. And you could basically just do everything, all that, the data wrangling and all that. you could have just a huge. Imagine this was the 90s. We could have all this in one application that does this, everything in one go, and then you change something, and you have to change a lot of things in many different parts.
Yeah, and this also makes this automation possible, right? So I don't know if you know AutoML. So basically, when we're doing machine learning on machine learning, so instead of us deciding what algorithm to use or what transformations to make to the data, we just let the machine learning algorithm to do that on our behalf. So then we can automatically trigger retraining based on some statistics changing. And then the AutoML part will try some different transformations of data, try a different model, more complex model automatically, and then decide which of the models is the best, and then deploy it into production. And that's kind of why we need that API for doing
that's again, that's beautiful, and it's a little bit scary, and also a little bit bad from, well, I don't know, bad, but dangerous in that sense that you get systems that are basically black boxes, and you have no idea what's happening inside. How about I don't know if these are the correct words here, but like ethical considerations.
Exactly.
Or if you're trying to do you're creating credit ratings for people, and suddenly it could be that it's not allowed, or it's prohibited by law, that you have a model which just gets input and produces output, and you have no idea why the output is what it is. It could be the perfect predictor of someone's credit rating, but creditworthiness, but it could be illegal.
Yeah, that's exactly what has changed during the past 10 years. So the role of a data scientist is no longer that they are the expert on machine learning algorithms, or what kind of tricks, what kind of hyperparameters you need to tweak to get the best result out of something. No, it has become to be an expert of explainability of the model, which is what you just said. So you in some cases you need to be able, and you might even if you don't need to, you might want to understand why the model makes decisions, what the parameters are, and bias detection. So find bias in actually all phases of this workflow. The bias could start with the incoming data, that we have bias distribution of data. It could be enhanced during training, so that the bias is actually something that the model picks up instead of disregarding it when making decisions. And then all the way to making the actual decisions and checking when you're making predictions that bias doesn't have an effect. And this is basically statistics, right? So we know how to do that. It's not like you need to watch at the numbers really, really, really closely and then do something. But rather, it's statistical procedures that we can use. And that seems to be the new role of the data scientist in our organization.
Yeah, that's interesting. And this is actually one of the questions I have on my list is what happens in the future, and was it AutoML? So that's kind of what is happening already, but this is probably the future, in that sense that it will take a large role. But how about the future? Do you see some emerging patterns that where all this is going, or is it about better algorithms, or faster machines, wider usage of ML? What do you think?
Clearly, large language models are emerging or have emerged. So we don't really know what we can use them for. But this whole idea of embeddings and then transformations or transformer architectures, it currently has been used for, ChatGPT and image generations and so on. But there might be additional things that we can actually do with them. So kind of finding those where we maybe don't train the model with all of the text in the internet, but rather something else, could be fairly interesting, because we can see that now we have some complexity in place that can solve lots of problems fairly easily. If we could use that complexity for different kinds of problems, that would be really interesting.
Okay, how would one get started with MLOps? What would you do?
Take one of our trainings, right?
Of course, but to be a bit more generic, when would you go into MLOps? If you've tweaked around with an algorithm that predicts something that might be useful for your organization, what are the next steps?
Yeah. So, oops, sorry, I didn't want to take you away. So kind of what you need to choose is a framework. So there are multiple different kinds of frameworks for creating these workflows and automate them. Now, depending on the cloud provider that you have, they might either have a custom specific to that cloud provider system in place that usually is easy to use and easily integrated with everything else in that cloud provider. Or then very often they have like an open source option available. So you could do this orchestration using Kubernetes. So there are frameworks available on top of containers that you're then running in a Kubernetes cluster. And then there are more custom options. Like for example, Apache Airflow is one of those, where you rather write Java code to plug things together. And then Airflow makes sure that that process gets run properly on your behalf. But similarly to CI/CD pipelines, you know that there are multiple options available. It's the same thing with MLOps. They're just a little bit more specific, you know, regarding data stores, artifact stores, and so on. Not as generic as CI/CD pipelines, but you use them in a similar way. And then you need to choose basically your pick your poison. But all of the cloud providers have these available because it totally, like you said, it makes sense.
Yeah. Okay. What else? Are we running out of time?
Yeah.
Let me figure out something else to ask you.
Must be a difficult question.
Something difficult. What are the problems of MLOps? Are there any pitfalls or something that you would want to avoid?
It's the same as DevOps, right? So building up the infrastructure for a project is fairly time-consuming and complicated for the first time. Once you've built it up, then it runs.
Yeah, that's the whole idea, that it runs, right?
Yeah. So finding the point when to go for MLOps is fairly important. If you're just running a proof of concept, it's not worth it, right? You're going to do work and then most likely it will get killed. So kind of figuring out when you haven't gone too far into creating stuff so that you can still adapt to an MLOps framework, and then doing that, having enough time for that in your project schedule and all of that is
again, from the software development point of view, I know that once you have built something, then it's kind of, you stick with that, and if you go one path, you're going that path, and it's fairly, especially if it's something that takes time to change, then you don't have the time or the budget, for, like from the money point of view or from the time point of view, you don't have. It's difficult to change.
Exactly.
Especially if the management doesn't see the benefit, the short-term investment, which it takes time and money to build the pipeline and test it out, and and make sure it works properly. That takes time. Let's say it takes, let's say it takes a week, just a number. But if you're on a tight schedule, then 1 week of not being able to do any billable work might be something that you're not allowed to do.
Yeah, it's executive sponsorship. It's kind of the way to go. It's the same with DevOps transformations. And another thing is that this doesn't maybe happen overnight. So you can start with kind of automating one part of the pipeline, let the others be there. Very often you already have an automated data pipeline. It should be easy to just plug in. So it's a journey, but hopefully anybody who goes on that journey will then see that there are benefits at the end.
Exactly. All right. Any last words?
Nothing else except for thanks to everybody who's been watching. Sorry about the weird technical glitch we had there in the middle. Let's see, maybe we're going to edit this episode to make a
maybe we just cut the weird part away, and then
it's going to be you doing that.
Oh yeah.
All right.
with my video editing pipeline.
Exactly.
Very efficient and complete.
Yeah. Thanks everybody for listening to us. I hope you enjoyed it. Please give us feedback in case you have any topics that you would like us to tackle, or anything else that you would like to say to us. Otherwise, we're going to see each other again next Saturday at 12 o'clock GMT, 13 CET, 14 in Finland, and so on and so on and so on. So till then.
Bye-bye.